Welcome to this Broadcom video on the integration between AAI and IBM Workload Scheduler for z/OS. This is the overview. In this video, we outline the integration of AAI and IWSz, called IWSz Server for AAI. It makes it possible to extract data from IWSz and make it available to the AAI server so it can process and then build its own database. From this point forward, we'll refer to IWSz Server for AAI simply as the software and its individual instances. The software makes two types of data available to the AAI server: operations data called events and definitions. We provide high-level details of the installation, preparation, and implementation. We describe an instance architecture, steps in the installation and deployment procedures. We want to make sure that technical concepts around datasets, libraries, and file system are completely understood. By the end of this video, we should know how to start the software's ISPF-based user interface. This is the software instance architecture. We start with three systems: z/OS, the AAI host, and a third system hosting a connector component between the two. This is the Apache-based connector developed by Broadcom. When installed, the software creates items in both the USS environment, but also in a z/OS-D. The basic configuration has these z/OS components installed once and shared by all instances of the software, although it is possible to install the full package for each instance. At the core of the instance, we find the server STC. This is the server process running continuously in the USS environment. Its purpose is to generate several sets of files containing event, plan, and definition data in a ZFS file system, which is mounted at IPL time, for FTP or SFTP transmission to the AAI connector. First, server STC uses an IWSz program called EQQbatch to generate a file called events, which contains the IWSz event data, executions, times, and so forth. The data is acquired from IWSz logs. The acquisition cycle is set to 1 minute to guarantee proper syncing of IWSz and AAI. Server STC also generates files containing the IWSz current plan, which includes current and previous plan data, containing current and future executions, as well as tracking audit data for past executions. This data is necessary to report statuses. For this, server STC spawns a child process that uses two IWSz programs: EQQbatch, which we've already mentioned for the current plan, and EQQycane for the previous plan. The files are called cpop and track for current and previous, respectively. The files are stored on the ZFS file system and sent to the AAI connector over FTP or SFTP. The default execution period is once a day. Server STC spawns another child process using IWSz program EQQycane, which we've already mentioned. This sources periods, definitions, and application data and generates the corresponding files in the ZFS file system. They are defs and base objs respectively, and are also stored in the ZFS file system before being sent to AAI. Definition data is static, which means very low acquisition cycles, in other words, once a day. The initial server STC start is executed with an instance-specific JCL. This invokes bpxbatch to start the Unix environment and then passes a Unix executable as a parameter. This executable, called AIST SRVR, is the server STC code. We have additional elements. The software contains an ISPF-based user interface called IMS, or Instance Manager System. IMS handles the management of software instances. It relies on a library called custlib that contains the JCLs and clists needed to administer via IMS. IMS can support multiple instances of the software. This means we can deploy more than one software instance in a given LPAR or across multiple LPARs. IMS makes it possible to manage all instances through a single interface. When a software instance is configured, settings are stored in an instance-specific dataset called SRVR-SCFG. Finally, we have a second STC called request STC for the shutting down of the server STC. Shutdown can also be initiated via IMS. SRVR-SREC is a dataset that contains one of various 4-character codes: Open means server STC is not currently processing and is ready to accept new commands. Another is CLSD for closed, meaning server STC is unable to process new commands. Both request STC and shutdown initiated IMS check that SRVRS rec contains open and overwrite with the term code to instruct it to shut down. Once this happens, the STC writes the code CLSD for closed. Other possible codes include those associated with definition data requests, like ADEF or JDEF. ZOS libraries are installed once and shared by all instances. However, deploying to a different LPAR requires a new instance, but only the Unix components. For this reason, the installer will provide two options: either full install USS and ZOS, or USS only. Let's go over some of the terminology. The server STC is a USS started task that runs the software processes. It is started by a JCL, which invokes BPX batch and passes the server code Unix executable as a parameter. It assumes a number of functions. It invokes several IWSz programs to extract event, definition, and plan data. First, it generates events on a 1-minute cycle. For this, it leverages an IWSz program called EQQ batch. Second, it spawns a USS child process on a very low cycle, say once or twice a day, which invokes another IWSz program, EQQ to generate definitions. Third, it spawns a second child process to generate current plan data via EQQ batch and EQQ again on a low cycle. Current plan is part of the overall event data package. Finally, a ZFS file system is mounted in USS at initial program load. This ZFS stores the acquisition data, events, and definitions for AAI. Server STC triggers FTP or SFTP to send the files to AAI via the AAI connector. The request STC is a transient process that handles the shutdown of the server STC. It does so by issuing a term request to the primary server. SRVRS rec is then updated with the CLSD code. The process starts, issues the code to the dataset, and then finishes. AAI needs the following files. Events contains event data for a specific time span, say the last 2 minutes. CPOP and track are two files containing current and previous plan data, which is part of the event data. These files are generated by programs EQQY and EQQ batch. Together, files defs and base objs form the definition data. They are generated by IWSz program EQQ IMS, or Instance Management System, is an ISPF interactive menu that administrators use to manage their software instances. We can add new instances, update, manage, trigger a shutdown, and much more. CustLib is the ZOS library that contains all the JCLs and clists necessary to manage IMS and the instances. Since IMS is common to all instances, CustLib lives on the ZOS-D. When an instance is created, a JCL called AITS followed by 4 characters is generated. We execute this JCL to start the server STC. It invokes BPX batch, which initiates the USS environment, then passes a Unix executable as a parameter, AIST SRVR, which is the software server code. SRVR SCFG is a dataset that stores instance configuration data. Each instance has its own config dataset, in which we'll find the instance's name, source IWSz Server, destination AAI server, connector details, file transfer methods, data acquisition cycles, and more. SRVRS rec is the dataset in the instance that reflects the state of server STC. When the STC is active but not processing, the dataset contains the code open, indicating it's available for new processing. When the STC is brought down, the dataset contains the code CLSD. Finally, the connector is a component installed on a dedicated host to support the IWSz integrations for both mainframe and distributed sides. This connector handles transactions between IWSz on the mainframe and AAI. The IWSz connector is a custom Tomcat web server and will show how to install and configure on Windows. Since it's Apache, the procedure on Unix is identical. Let's outline the procedure for installing and configuring IWSz Server for AAI. First, we perform all initial preparations. A few things are required. We need the Rex library made available to all LPARs where at least one instance is going to be created. A product directory is needed in USS to install the Unix files, and a few more things. Then we download the install package from the usual download sources. We unzip the file and upload to the mainframe. The package has the pax.z extension. We start USS in the LPAR we want to deploy to and copy it in a temporary directory. We use the pax command to unpackage the file. We start the installer. The installer presents two options. We can either perform a full installation, which installs both ZOS and Unix components, or the USS module deployment only. We then execute the cust libc list member AITC prim to start the IMS UI. IMS is our main user interface. It gives us the ability to create new software instances, configure or update an instance, and so on. We're given a choice between CA7 or IWSz, and so we select IWS. We create a new instance, set basic aspects like HLQ, LPAR and colors, and allocate datasets. Then we configure the instance, the IWSz server it's sourcing from, the AAI connector it's sending to, and the software itself. The ZFS needs to be mounted at IPL. For this, we use a JCL that we add to BPX PRM XX member in sys1.parmlib, which is generated once the instance is configured. We add the server STC to the ZOS automation services. We install the IWSz connector on a dedicated distributed system and configure it. Finally, in the AAI web UI, we add the IWSz scheduler so that AAI is able to consume those data files. Let's consider some deployment scenarios and the impact on the instances. Let's imagine a mainframe with two LPARs. The first LPAR has two IWS subsystems, while the second has a single IWS. We also have two connectors. Each IWSz subsystem needs its own software, and each software instance can communicate with a single connector. So instances are mapped to single IWS and single connector. Otherwise, multiple instances of the software can communicate with the same connector as long as they deliver to different directories, which means that the same AI host can source data from multiple IWS subsystems as long as you define a connector for each with a dedicated directory. This is consistent with single pane of glass management. So we could support a setup with 3 IWSz subsystems and 3 software instances mapped to each one. Then you have 2 AI hosts and 2 connectors. Instances 1 and 3 report to AI host 1 over the same connector but in different directories. Instance 2 reports to AI host 2 over its dedicated connector. This is possible. Let's consider what's not possible. You cannot have a single instance of the software mapped to multiple IWSz subsystems or reporting to multiple connectors, irrespective of IWS. A software instance is always mapped to a single IWS subsystem and always reports to a single connector. This is the navigation map. We execute the installer in USS with /AISZ_installer. This initiates a menu with 2 options. Either USS module only, which we use when the software has already been installed and we're targeting a new LPAR, or full install, which we select if it's a first install. This installs both the Unix components, but also the ZOS libraries common to all LPARs. Once installed, we execute the AIZC prim clist in the cust.lib library, which starts IMS. IMS gives us 2 options, either CA7 or IWS, which we select. In the Instance Manager menu, we have 4 options: A for Add, C for Configure, U for Update, and M for Request menu. Adding has a sequence of 2 screens. The first captures the name of the LPAR automatically. You also enter the AAI and IWSz subsystem IDs and set a color theme. The second menu contains the dataset allocation functions, sizing, and so forth. It will also prompt you for the high-level qualifier, which will serve as the base HLQ for your install. Configuring means entering the AAI connector host settings, which we deliver data to, the IWSz subsystem we acquire data from, and the software itself. We use the Update menu to make alterations to the configuration. change HLQs, rename the way the LPAR appears in our interfaces, and regenerate JCLs in the event we change the HLQ. Finally, we use the instance request menu to access the software log, trigger a manual delivery of the definition and event data, and generate the ERTA online report data. Finally, we can shut down the instance. These are the elements you should download from the Broadcom site in order to perform the installation. You obtain the main AAI installer package that contains all the elements, AAI files, connectors, and so forth. In the connectors folder, look for a zip file identifiable as applicable to the mainframe. The current version is labeled Data Provider. In this file, you'll find a pax.z file, which contains a number of files, such as the AIWSz installer file, which is the installer. In the same download package, look for the IWSz connector zip. This contains the connector install files and looks like a common Apache Tomcat file system. Thank you. This concludes the video.